Just yell.
Yeah, we'll just yell louder. Okay, great. Well, I think it's recorded, so that's important. Okay, welcome to Yet More Edge. I think I would pretty much safely say that this OpenStack Summit, it can be summed up in three words: edge, kata, and more edge. No, NFE is passé. No, edge is the buzz. So welcome. This panel is made up of people who've been working on the edge in various ways for quite a while, and I'll have everybody introduce each other quickly. But we're going to focus on the security of the edge, because I think security is really important and should be started like right from the beginning. And we've been working on edge I'd say we're definitely still in the beginning, as probably as you can see from all the sessions this week. And so it's a good time to talk about the beginning. So we're going to do quick introductions, then we're going to talk about some of the pain points, and some of the things we need to address them, and then sort of next steps. So with that, Rob, why don't you?
Sorry. Hello, my name is Rob Hirschfeld. I'm CEO and co-founder of a company called RACN. We specialize in physical infrastructure automation. So the very basics, building the infrastructure from the ground up, and we do it in a way that is very lightweight, easy, self-contained, and very edge-friendly, edge-focused. I spent a lot of time, I served as four terms on the board of the OpenStack Foundation, so I've been around in that, and I've been working on Kubernetes, community and operational components since my term in the OpenStack board. And then I've been running a podcast where we focus on edge infrastructure discussions quite a bit, called The Latest Shiny. It's the only podcast that starts with L and 8. So easy to find if you're interested in hearing some really great guests talk about edge infrastructure.
Thank you.
Okay, hello everyone. My name is Shuquan Huan, Technical Director of 99 Cloud. 99 Cloud was founded 2012 in China. We are providing the OpenStack cloud solution to our customer. Our customers are in the many vertical industry of China, including energy, financial banking industry, and many others. We are focused on providing cloud services since several years, and right now we think the cloud computing will evolve to the edge computing, especially in many use cases such as smart city and industry 4.0. So we are turning to the edge computing as another direction.
I'm Glenn McGowan. I'm Principal Architect for Service Provider Solutions with Dell EMC. My primary focus is on NFE, telco workloads, and far edge use cases like SD-WAN and UCPE.
Excellent, thank you. And I'm Beth Cohen, and one of the co-founders of the Edge Computing Working Group at OpenStack, the principal author of the Edge Computing white paper that was sponsored by OpenStack, and general ne'er-do-well at Verizon. Okay, so edge computing has been all the buzz. I think you've been hearing about a lot of the different use cases. So let's talk about the elephant in the room, the pain points. So who would like to talk about some of the places you need to?
I can start, because I think one of the things that's fundamental with edge is the actual IT. And when we're talking about edge, in a lot of cases, we're not talking about the devices. We're talking about the IT infrastructure at the edge. But I think we'll talk about devices too.
We'll definitely be talking about the devices.
My focus area has been the actual IT infrastructure. So if you want to think about the next hop back from the device itself, and in those cases, what you're talking about is an IT environment that is very vulnerable compared to what we're used to thinking of for IT data centers. So you're talking about servers that are in environments where there is minimal security, where the actual physical presence, the physical sites are not monitored. It's very easy to get physical access to the servers, to interrupt the networking security, to find out what's going on. And so when I look at the security posture of these environments, it's not just that we have potential for network intrusion, but they're physically accessible, and you can actually break past the physical barriers that we normally count on to keep IT infrastructure secure, and get access to the systems directly that way. So that's a major focus.
Glenn, I think you as
I haven't broken into any data centers recently, so but I think with the focus of cloud right now, everybody uses the term disaggregation. And if you look at things in the past, things were sort of monolithic, everything was compact, and the attack vectors were, fewer, right? You had everything sort of, it was a very hardened ecosystem. Now that we get into disaggregation, we get into situations where we want to be able to take these components and mix it with that component, and this, that, and the over there. So we lose that ability to do, or we lose focus, I should say. We have the ability, but we're not necessarily focused on the security aspect of when we're doing those integrations there. So I think that coupled with the physical security aspect to me is a real thing. I'm wholeheartly in favor of disaggregation, but it's one of those things that we have to look at when we take the opportunity to assess a disaggregated solution.
Yeah, from my point of view, I think the edge computing security may contain two categories. One is the security problem edge computing inherited from the cloud computing, because edge computing you also have to manage the infrastructure, IT infrastructure, right? So the cloud computing may have the security problem of cloud computing may also happen in the edge computing. Another problem is the new things happening in the edge computing. For example, the edge computing may related to some smart camera applications. Those smart camera, it take the faces of people or say some sensitive data from the people. We have to especially care about those privacy problems.
Yeah, I would agree that there's a number of surveillance. I know there's a presentation by a person from the city of Messina in Italy who's proposing a type of edge computing, which is a surveillance camera. So clearly there's some security issues there. From my perspective, I think that edge computing adds new vectors where there's potential for break-in. So, data centers are generally fairly secure. So, physical access is pretty limited. Yeah, I mean, it's possible, but generally, there's enough cameras around and enough security guards that it's likely to be limited to the security guards being the the vectors. But as has been mentioned, when you have it out at the edge, it's likely to be not only in areas that are not necessarily monitored, but they're also in exposed areas. So another security aspect I think that we need to consider is, cell towers and remote locations like in Army, in war situations where there is, it's not only just security from the, sort of the IT perspective, but physically somebody can blow the thing up. So there's definitely additional vectors that we need to consider. So with that, now that we've identified all the scary ways you can break into this thing, so what are some thoughts about how do we address it that's different from what we do in the data center?
I think regarding the sensitive data taken by camera, maybe we have to make some regulation rules and make sure how the vendors, how to protect those data, store this data. Another aspect is we have to make sure the mechanism or some authentication mechanism in the edge computing infrastructure. As we know, edge computing infrastructure, it can work as itself without connect to the cloud. So even the edge computing infrastructure was broken by someone, it can also protect itself.
So isolated. So how would we add that into the infrastructure? I don't think that exists today in the infrastructure.
One of the things that we've been looking at is a lot more encryption capabilities, making sure that any data that is stored on these infrastructures is stored in an encrypted way, so that if somebody comes in and pulls a disk out or a machine out from that system, that the system itself is not readable. So, right, you have sensitive data in these edge locations. I mean, we do today, right? We already have, telcos who have a lot of very sensitive information in the POPs, point of presence sites that they have. I think that, and those they secure because the telephone facilities are secured. But if we're building these edge infrastructures and not putting down encrypted data as a starting point, right? Trusted platform. Most IT systems have trusted platform modules. They're just very tricky to set up and manage, right? There's security embedded in infrastructure that we're not enabling by default now, in part because it's not well automated. And so we need to sit down and say, all right, if we're going to build these edge infrastructures and we're not using the inherent security pieces, then somebody can walk in, take those systems, and then recreate or get access to our infrastructure. And that's the starting point. It's just turning on the things that we have available.
Glenn?
Yeah, and I think just to add to that, we have to look at a prioritized model from a security standpoint. I mean, sure, we need to be physically secure, but I think the more likelihood being connected to the internet, you're going to have much more opportunities for attack versus opportunities for physical attack. So in that case, I guess one solution, we all want to live disaggregated. We all want to leverage the software in a sort of modular way. So one thing that maybe needs to happen is we're, as a community, we tend to gravitate towards frameworks. And I think a framework is important because it also allows us to be disaggregated, but it also provides at least some level of standardization to ensure interoperability. And I think we can build on that in terms of extending that interoperability into a common security model and things like that.
So I have a question for you on the disaggregation point, because it seems to me that in these models, we have a lot more devices connecting into our platform, right? We have IoT with very minimal code bases. They're very lightweight. They have to be lightweight code bases.
Bare metal usually.
Having a trust basis back into our application platform, in addition to the users. So we've got a lot of. I mean, this graphic shows just how vulnerable all of these endpoints are. Somebody hacking into your baby monitor, your camera, your thermometer potentially can get
already happens.
Encryption that somebody can use to go upstream back into these systems. Is that what you're thinking with disaggregation?
Yeah, and it's that, but it's also just the sheer number of APIs that we have that are exposing REST APIs between different software components that were potentially developed in single silos that didn't have a common security mindset. So there's that one piece. To your point, I think maybe you're referring to some of the zero-touch provisioning where we may be deploying an edge box out at the site. It's going to potentially authenticate back to the mothership, and you want to make sure that the person that has that device is the person that is responsible for owning and maintaining that device. It's not some outside actor that's either intercepted the package or something like that is.
Right. Well, and that's where, to me, you look at what we saw with WannaCry and some of these vectors where people hadn't been patching their infrastructure. Yeah. And so there's a big part of the edge vulnerability when you're talking about tens of thousands or millions of sites is you have to have ways to keep the system up to date and patched in a constantly ongoing basis, right? The idea of being stuck on Windows 98 as your for your ATMs being running core infrastructure can't be in a out of date system.
And ATMs run Windows XP.
Yeah, another thing I want to add is that when we set up the edge computing infrastructure, we have to make sure it's also secure enough. We can leverage the experience we are building cloud infrastructure. As I know, OpenStack has a security group, right? They are making a lot of checklists for the security. For example, do you still use what kind of token you're using in the keystone and what kind of hash mechanism you're going to use. So we can leverage those past experience when we set up the edge computing infrastructure.
I think those are good starts. I think, at least in my opinion, what I would want to see is maybe some sort of validation. When you're adding components into the OpenStack framework, you're evaluating it through a common security model. I think, we talk high level through, RBAC and, Keystone, federated Keystone, those types of conversations. I think those are good, but in terms of reducing your attack vector and, making sure that we have a united security model, I think is important to,
Beth,
Yeah, I'd like to add, because so we as Verizon have already smacked into this problem with our product, which is that our customers are asking when we ship a box out, which we're shooting for zero-touch provisioning. They want to know that if somebody intercepts that box, that no secure data will be exposed, A, and B, we don't run into regulatory problems. So this is another vector that needs to be considered. So for example, we're downloading security and network services, and some of them can only go to certain countries because for security reasons and regulatory reasons. And we need a way to assure our clients and our customers that when that box gets shipped, if somebody takes it and plugs it in, someplace else, that is not broken.
And this, to me, you mentioned Keystone, right? This is one of the challenges to me. The IT infrastructure that we've been building has assumed that you were in physical proximity in a controlled environment where you could build a TLS, a trust certificate domain, where you're able to say, okay, I know all the machines in this system. I can actually, communicate securely with nobody in the middle. As soon as we start shipping boxes out, you can't use Keystone. You can't just set it up as a Keystone endpoint because you don't actually know the verification of that box. It could actually be moving over a network which has been compromised, even with the TLS infrastructure, depending on how it's been built. So it's not as simple as a lot of the security tools we've built aren't designed to not trust the client, right?
Yeah, it has to be based on, I think in the case that we're talking about here, there's two-factor authentication and some things, that we can do with
and
GPS.
we also don't ship the boxes with the images.
Yeah, so, but in terms of what you described there, because of that same issue, an external attack, once they get in, because you have a common, plane there, you can now reach inside the entire cluster. You have access to everything else that's in that same node. It just becomes sort of a, you crack this one little, vulnerability, and then, the gates swing open. And I think that's a huge problem right now in our connected, sort of federated, single fabric, single pane of glass trajectory.
Yeah, you going to add in?
No.
I was going to say, so one of the things, and you see this in the Kubernetes installation, where Kubernetes has good requirements where they require you to use SSL, TLS encryption, but people have a tendency to only use one key pair for every service because it's very difficult to create a lot of different key pairs. And so one of the things that we need to be very conscious of doing is as we create these trust channels, we get out of the habit of saying, oh, all of these communication channels can use the same trust or the same identity or
we
the
have
same
to force
certificate.
There's no question. We have to force single certificates per box. And that's how we're doing it.
No, I think, we have to be very careful and not being heavy-handed, but, there needs to be some level of responsibility for creating a multi-leveled security model.
But I don't think that's heavy-handed. I think we're missing the automation to build things in a secure way so that you can, right? And this to me is the challenge, right? It's easy for a developer We don't want all these pieces to come in, right? And it's funny because developers often don't want the level of automation that we need in the field because it gets in the way of doing good development work. If you were trying to encrypt, right, OpenStack didn't require HTTPS among its services because it's a pain to set up the certificates to make all that stuff work. And with Kubernetes, the major stopping block with Kubernetes installs is actually building certificates because they do require it.
Yeah, I want to, from my perspective, I think I tend to the multi-level security. As you just mentioned, the HTTPS is hard to set up in OpenStack, but in edge computing, there's many use cases. Maybe some of them, they are use OpenStack. And if in these cases, the security requirement is you have to use the HTTPS stack, we have to improve the setup process in OpenStack, right?
It has to be a default requirement.
Yeah.
I agree.
At least in our product, we are default turn on the HTTPS.
Right, but I mean, and HTTPS is one thing, but now if you start putting OpenStack in edge environments, right, the database becomes a vulnerability because that's data at rest. The message buses become vulnerabilities. These are all challenges, and then if you spread that over a WAN, then
Yeah, I mean that's another point. I mean SSL, SSH are minimum requirements in my opinion.
It's a minimum requirement.
Yeah, because if you're getting into where you're in a sort of multi domain deployment where you've got WAN, LAN, data center, and different variations of the edge deployments, you're transiting network segments there that are untrusted in a lot of ways, things like that. So that's where IPsec comes in. You're establishing IPsec tunneling and those sorts of things. So
yeah, that may be total different architecture.
I mean, honestly, if we want to be as stringent as possible, why continue down the path of SSL and SSH? Why don't we go to secure tunneling between all of the services and components to harden as much as possible? Instead of I'm not saying minimum effort, but I'm saying let's start now building a robust a solution as opposed to just meeting the requirements of the day, because the bad guys are 10 steps ahead in a lot of cases. Some of the good guys are too, but we're not getting the vulnerabilities patched fast enough.
Right, but if you have a good distributed key infrastructure, right, and this is in a lot of cases the whole edge security thing becomes wake up, realize how vulnerable you actually are. Even if you sat down and said, hey, I've got this thing licked, I've done a TLS infrastructure, I have a public-private key, I'm using HTTPS for all of my services, I'm secure. If you haven't worked out a key rotation strategy so that you can roll out a new key, then if your key becomes compromised across 1,000 sites, especially if you're using the same key generation, right, the master certificate. In those cases, you now are just as vulnerable because somebody can get on that encrypted infrastructure using generating their own keys, or they've managed to capture a node.
And it's even worse because that key issue goes all the way down into the TPM components of the hardware infrastructure. And when your keys are compromised, how do you do that? How do you update your hardware keys?
So how can we incorporate that back into the requirements for the OpenStack requirements?
So
that's my call to action.
So part of what I see us needing to be able to do, and I'm talking about immutable infrastructure in a couple hours, is we need to be in a place where it's not just I set this environment up secure. It's I am constantly reconfiguring, setting it up. I'm tearing things down. I'm changing the keys. I'm doing rotations. If you're not thinking through not just a secure setup, but a constant turning of that environment, then you really aren't secure. It's not just a matter of doing it once.
Yeah, I agree. I think the security is constantly you have to repeat the process, maybe to review it and update your system according to the environment changes.
And one other note is, I would want the systems to be smart enough to recognize that they've been compromised in some way and be, more proactive as opposed to reactive or needing some human to say, hey,
Take themselves out of the loop.
Why do we have to detect it?
Yeah.
I mean, the systems, we can set up some parameters and maybe even some AI to be able to determine that it's been compromised. And we're in an AI generation now, right? We can use AI for that kind of thing.
I agree with you 100%. I think we need in edge infrastructures to set aside capacity to do active security scanning, right? To make sure the devices that are connecting are the trusted devices. If there's things that look weird, start taking proactive action, shutting systems down, taking you off the network.
It definitely should not be a, hey, something's happening, let's wait for something to be compromised. Let's look at what's happening, assess that, hey, there may be something that's happening here. I'm going to start taking steps to sort of secure or redirect or redivert or whatever.
But based on the data of the infrastructure, you can do some prediction.
Well, actually, the next-gen firewalls already do that. So we have that capability. It's just a matter of bringing it back down into the infrastructure.
They do that from a traffic standpoint, but I think from an infrastructure and, it's almost becomes a big data type of problem, right? Where you need to take all of these parameters in and analyze them and understand, okay, there's something fishy happening here. I need to either notify somebody or I need to take some steps to start locking things down.
Well, this to me is a great place where we're talking about a lot of devices connecting into your data center. There's got to be a whitelist, blacklist capability, right? So in a whitelist case, we're saying, I'm not allowing you into this edge infrastructure until you've gone through some authentication process. And then once there's a signature established, then you could actually monitor and say, somebody's tampered with this device, there's a signature. But now we're talking about hashing somebody's environment operating system to make sure that you haven't touched it. If there's an update, you have to track all those things. So if the thermostats all take a software patch, then their signatures change, and you have to be willing to say the old signature is bad, the new signature is good. These are significantly hard problems.
But that sounds like something that would be akin to like a blockchain for security or something like that, where you could do. Well, I hate to invoke blockchain. Sorry, was that hype? Somebody's going to start throwing tomatoes. I'm sorry. Yeah,
it's true though. I think there are applications for blockchain in edge. I think it has to be from a distributed trust perspective.
Yeah, in China, I saw some blockchain company. They are involved this security, some mechanism into the infrastructure. They talked to me, so you can just by default enable the blockchain in your cloud so that you have more security mechanism. Some startup they just working on this.
It might be worth taking a second to explain why blockchain is a fit in this case and how important it is.
I think that would be a good idea. Yeah.
I don't know. I think let's start with the hype. I think with blockchain. Let me just kind of throw out.
It's not just Bitcoin.
Yeah, it's not just Bitcoin, but let's use Bitcoin as an example right now. Bitcoin is a very large set of network nodes that are constantly evaluating the ledger and looking at transactions, hashing those transactions, comparing those to the ledger, and there's consensus across the network to make sure that those transactions are legitimate. I think in a Bitcoin network, which I think we can all assume is very large, it's probably possible, but where I start to become a little skeptical about is when you want to deploy blockchain in smaller sort of enterprise environments where you don't have this big consensus of miners sitting around there to constantly evaluate. So the opportunity for bad actors to get in there and potentially create situations to where you could, maybe forge the ledger and because there's not enough people out there that have the correct ledger or the actual ledger to do the comparison and basically call BS for the bad actor. I think that's a potential for problems, and that's what I would say is a challenge.
I think the cryptocurrencies have inherent flaws that are not necessarily relevant in the edge security case. And I think when you look at the system, we're talking about a relatively defined span of control in which everybody in that system, everything in that system, cares about the integrity of the environment. That's a distributed trust environment, and it doesn't require a lot of cryptographic overhead to maintain that. But because this is a two-way thing. It's not just that we're trying to protect the servers that are in the edge data center. Every device that's connecting to that needs to be able to trust that environment and needs to know that every other device in that environment is trustable. And so that becomes actually a very good distributed trust environment, which is where a lot of the interesting blockchain, in my opinion, blockchain applications are coming from. And so if you have a way to say, I can identify every system in my environment, and when its BIOS is patched, the blockchain is changed, and I can then I can cryptographically certify that the things I'm talking to are trusted. We have to have things like that.
I agree. I think where I question the issue is the whatever the miners are going to be, the equivalent of that sitting in an enterprise environment for validating that transaction. Today we have a large number of nodes within, say a Bitcoin network that's doing that validation, and it would take an incredible amount of CPU power for somebody to cheat that. You would need to basically replicate that, I guess, in the current iteration.
There are some much less expensive algorithms.
Yeah, I'm not an expert of blockchain, but just mention, I think the blockchain maybe just resolve the trust problem in vastly distributed system. So in the edge computing cases, we distributed the nodes everywhere. So blockchain helped to resolve this trust problem. But I think in the security perspective, there are still many problems we're going to resolve. So I have a question maybe to you guys. What do you think the top 3 or top 5 security problems for the edge computing?
For me, it's lack of a common security framework. We're disaggregated. We need to come to a common, sort of consensus on, how do we do this and plug in the different. We have to be disaggregated, no question about that. But we need at least a common framework to ensure that security.
For me, it's the lack of ability to assert and automate where that something is up to date, patched, and changed. And so when I look at the vulnerabilities, a lot of times we fix vulnerabilities very quickly, and then we don't have ways to assert that they're correct, and that they've been propagated.
So we're always chasing after the bad guys are ahead of us.
The bad guys are ahead. Well, I think they are, but the challenge is if we find a vulnerability, and we're talking about tens of thousands of edge sites, if we don't have a way to propagate that within days or hours,
right, then
what we've effectively done is we've allowed that compromise to be easily exploited.
And zero-day exploits is a significant problem here.
They are, but most of the exploits that we see are not 0-day. They're 10-year exploits or 5-year exploits. They're not even that.
SQL injection is a solved problem.
They're not even that, right? So, and this isn't just a security problem. It's a bug problem. It's a patch problem, right? Edge is going to challenge us because we're not going to be able to deploy somebody with a crash cart and a USB stick to fix a bug. We're going to have to be able to say, this firmware patch is being rolled out to all these sites. It's going to disrupt the infrastructure that's there. We have to trust that patch is going in, because you could have a bad actor pushing that change through. So to me, when I look at edge security, and it's a positive thing, we have to be able to fix these automation problems and these that are fundamental to building good infrastructure.
And how do you clean them up? I think we didn't even touch on that topic. How do you go back and
so I'd like to, with the last 5 minutes or so, I'd like to open it up to any questions from the audience, comments.
Easy questions, please. This is security.
Well, the first is just a comment. Can you hear me anyway?
Yeah, we're fine.
Mike. So we've been deploying edge computing since the middle 80s, right? It just hasn't been edge cloud computing. I think
Correct.
The biggest security problems are the same ones we've always had. Network access is number one. When we screw that up, we need ubiquitous policy somewhere out there. That's a problem we have to solve. The real problem that we're bringing now is the same as the baby monitor problem. We're deploying these standard boxes that have standard exploits. Before, we were deploying some appliance that had some 8080 assembler code in it, and who knows what exploits there were in it, but no one could take the time to find them all because we had a zillion appliances. Now we're putting Linux boxes out there, and people go, oh yeah, I know what to do with that. I think that's
It's on the web. You just have to Google it.
I think those are our number one and number two problems, and then that takes you back to solving it with patching.
Yeah, so I think what you're talking about is sort of where I was going in terms of disaggregation. In order to support disaggregation and in order to provide that single pane of glass and that sort of thing, everybody sort of gravitates towards the same infrastructure, families, so to speak, and all of those families, to your point, have those same vulnerabilities. So, yeah, I mean, that's a very valid point.
Yeah. And you talked about big data and AI. We've been doing that for quite a while at my company, and that absolutely works. That's an essential part of the solution. You have to be able to identify when something's gotten nailed.
Yeah.
Great.
So any additional questions? Oh, there we go.
So great talk.
So Rob can answer this one.
Sorry?
Make it a hard one so Rob can answer it.
Yeah, it's for Rob.
Okay, good.
Yeah. I always battle with Rob at all the conferences. So I was a part of a NIST working group for IoT security, and they're actually building a framework to solve for some of these edge cases as it's the integration between IoT and security.
That's great because IoT has like orders of magnitude more problems.
So there are a few hardware vendors and projects working on lightweight attestation. So as you well know, TPM 2.0 is way too heavy for a baby monitor. So there's a combination of that plus the software on that and the notion of like SWID tagging to roll up some metadata for attestation. So there's some things underway. But I do agree with you, Rob. I mean, your camp on this thing of the remote management patch updates, because it's a huge problem. If we can solve that, I think we'll be on our way here.
Thank you. And TPM, if people aren't aware of TPM, most modern systems have trusted platform modules that you can use to attest that the operating system drives, components of the infrastructure are what you think they are and not boot if they're not valid. And so there are ways that you can do that. I have met very few companies, I would say none, but I'm sure there's somebody floating around who has actually turned on these features in their systems, because turning them on, especially for remote systems, means they might not boot. And then you're truck rolling because something jiggled.
Yeah, we have customers that turn that stuff on. Yeah. We do.
Yeah, as I know, in the China, there are some financial banking.
Yeah.
They are turn on these features, but most of all,
a lot of our financial customers require it. Yeah.
Awesome. How deeply would be my...
How deeply?
How deeply do they actually trust their TPM infrastructure? Do they...
Well, I mean, they're just paranoid in general.
Right, but I mean, you can, and I want to be careful on time.
We're fine. I'm watching.
So right. I mean, if you take standard Windows or Red Hat builds, they already have attestation keys built into them, and then you can use TPM to certify that the OS is what you think it is. If you start rolling your own, it becomes much trickier, or you're trying to verify the systems.
I completely agree, but I think the one benefit to rolling your own is that creates a different combination that is, to the other gentleman's point, something unique, right? So it doesn't necessarily mean that, if we all deploy the same cryptographic, solution, it means that anybody that determines there's a vulnerability with that solution is going to be affected across the board. Whereas if you roll your own, potentially, you got to know what you're doing. But
with the mutable, you're going to have to be rolling your own. You're going to have.
We
have
have time for one more question, and then we're done.
So it's a bit of a high-level philosophical question, but I wonder if we're letting the hardware vendors off the hook by focusing on software solutions, and maybe we should just say, look, from now on, if you want to deploy an edge hardware, we specify a bunch of requirements. If it breaks in, it wipes the disks. If somebody plays with the chip, it wipes the disk, et cetera, et cetera.
So those systems already exist in the military grade. Arena.
Yeah, so the hardware vendors are not off the hook. That is what keeps the hardware vendors up at night. At least this hardware vendor. That's why TPM is standard in a lot of the solutions that we have. It's at the forefront, right? We cannot deploy insecure infrastructure because that is the fundamental layer that everything is built on top of. If that is compromised, we've got big problems. So security is at the highest level, at least within my organization for these types of.
So I wonder where we draw the line between trying to solution it in the software or.
No, there's no line. There is no compromise, right?
Both.
We cannot compromise on security.
Yeah.
It's not a hardware or a software problem. It's an ops problem. Right.
Actually, it's a total system. To make sure your business security, you have to make sure no matter hardware, software, or your application, they are all security.
Thank you.
So thank you, everybody. I think we've run out of time.
Thank you.
So.
Thank you, everybody.